All right, today we're talking about circles, segments, and Pythagorean theorem. So there's a few other rules for how segments can intersect inside of a circle and their measurements, but I really just want to show you kind of two simple rules right here. Okay, so this first one, I just want to remind you, and this is a simple example, so we might look at a few tomorrow that are a little different, but I want to remind you that every time you see a radius in a circle, it's going to be the same. So for instance, if this line is x, right, this portion is x, then this side over here is also going to be x. So in this problem, we see that we've got this right triangle right here. So we can solve this right triangle out with Pythagorean theorem. So remember that the one across from the right angle is the hypotenuse. So I've got 8 squared plus 13.8 squared equals x squared. And I don't want to bore you with how we work that out because I feel like you all should know that at this point and probably do. So I've got, going to get this. Remember that at the end, you're going to take the square root. And when I do that, I get that x equals 15.95. Now, I want to just remind you of some things and kind of, this is what I really want you to get out of your notes here. One, this answer should make sense. Remember that the hypotenuse should be the longest side. So it makes sense that you're getting 15.95 because that's bigger than 13 or 8. One other thing they might ask you to do is to maybe find something like the diameter in this circle. So remember that this 15.95 is the same as the radius. So if they were to ask you to find the diameter, you would simply divide that number by, sorry, not divide that number by 2, multiply that number by 2, and the diameter here would be 31.9. So I want you to make sure you write that down so that you can see how you might solve for other things. All right, this second question kind of goes back to something we talked about when we were summarizing angles, and that is, remember that a radius and a tangent line, now the one we had drawn the other day kind of extended, right? But the radius and this tangent line are perpendicular, which means this right here is a right angle. So that means I can do, again, I can do Pythagorean theorem. Remember that 17 here is the hypotenuse. So I've got x squared plus 15 squared equals 17 squared. So I'm going to go ahead and work that out. And when I do that, I'm going to get that x is 8. So, but what I really wanted to show you is, again, how this relates to the circle. So this would mean that the radius is 8. So remember this right here is 8. That's the radius. In this circle, there's 2 radii. So like this other radius that you could draw here is also 8. And because the whole thing, it tells me this whole line that's extending outside of the circle is 17, right? That's 17. I can figure out that the outside portion, this outside portion would be whatever 17 minus 8 is. So the outside portion there would be 9. Now, I know that might seem like dumb to you all, like why would you do that? But you are going to have questions tomorrow that ask you those things. So make sure that you understand and rewatch the video, that little section, to understand where I'm getting that this outside section right here would be 9, because you need to know how I'm getting that answer. Okay, these last two problems kind of are very similar. You might not think that they are, but they are similar. And I'm actually going to start with question number 4, because I have a feeling that if you had question number 4 on a test, you could probably just take a guess on how to do it, and you would be right. These two lines are going to be congruent to one another. They look like they're the same size. They're hitting on the same side. These are the problems that I like to call ice cream cone problems. And the reason is because I think about like an ice cream cone, right? It's going to be the same on each side. And so these are going to be the same on each side as well. So to solve this, you would literally just set them equal to each other. 2x minus 1 equals 4 plus x. And you'd solve that, and you would get x is 5. Which is the answer there. If it asked you to find the actual measurements of those, you would plug 5 in. So you would get 9 on this side, and 10 minus 1 is 9 on this side. That checks itself out. The last thing, just for your notes that you can probably write down, is that these, wow, you cannot see that color. Let me change colors. Deal. All right, these are both radius right? So these radii, even though I don't know how long they are, they're equal to each other, which is going to be important at some point because you might actually see that in some problems. So I just wanted to point that out to you. All right, so this is going to do the same thing. And remember, I told you I call these ice cream cone problems. I see 4 cones here that match each other. So for instance, I see this 13 up here at the top, which means the other part of that is also going to be 13. And the question is asking me to find the perimeter, which means I need to know all the side lengths. So what I'm going to do is work my way around to try to figure out the other side lengths. So if the first part's 6.3, the second part is going to be 6.3. Now, on this next one, I don't know either side here, not those portions. But if I know that this whole length is 14.7 and the blue section is 6.3, I can do 14.7 minus 6.3 to figure out that other length. And so I'm going to get 8.4, which is going to match on this other side as well. Remember, this is like an ice cream cone, so those parts match. Okay. So again, same idea. I know this whole thing is 16.1, so this section, golly, that color is so hard to see. This section is 16.1 minus 8.4, which I think is going to give me 7.5 if I subtracted that correctly. I did not. It's 7.7. Ugh. So this one's going to match on the other side. So now when I'm finding perimeter, I'm just going to be adding the entire length. So I'm going to do 13 plus 13. Oh, sorry. Let's measure 13 plus 6.3. On this bottom one, don't count the 14.7 because you're already counting it if you count these 2 pieces individually. Same here. Don't count the 16.1, count the 2 pieces individually. All right, so if I add all of those together, I'm going to get perimeter. So perimeter is adding sides. And unless I missed something somewhere, I got the perimeter was 70.8. Okay, I'm sorry. I'm throwing in one more thing just because I think it's easy and something that you all can do fairly quickly. And it's, like I said, it's easy. So there's a general form for the equations of circles, and it looks like this. And the only reason I'm honestly showing that to you is just so that you are familiar with it, so it doesn't look hopefully too foreign if you ever see it again. If you remember from algebra, we used to do transformations, so you probably would have done this with T-Brown. You do transformations where what's inside is opposite and what's outside is the same. So these things that are inside are going to be opposite, the H and the K, and they're going to give you the center. And then the number on the end is whatever the radius was squared. Okay, so I'm just going to show you one quick example, and we can talk more about this tomorrow, but the center is going to come from inside these parentheses, and it's opposite of what it looks like. So that's not really a -3, it's a +3. It's not a +5, it's a -5. So the center of this circle would be at 3, -5. Okay, that's the center. Now, the radius, so how much you're going to count by, is going to come from this number out here. Now, remember, that is r squared. So some number times itself gave me 16, which means r itself must be 4, because 4 times 4 is 16, right? If you feel like you can't just see that right away, maybe you write down that r squared equals 16, and you're just taking the square root to find out what r is. Now, if the radius is 4, that's the distance from the center to the edge. So what I'm going to do is start here at the center every time and count 4 in every direction. 1, 2, 3, 4. And really, I just count kind of the easy directions. So I'll do this in red, to the right. I'm going to count 4 to the left. 3, 4. 4 up. 1, 2, 3, 4. And 4 down. 1, 2, 3, 4. And then you just do your best effort at sketching a circle. And that's how you graph circles and use their equations.